Hey, you. Atom Bond. Step into my office.
At your service. Bond. Gold metallic Bond. The one and only Bond.
I hear rumors of other bonds. I suspect some atoms are planning to take over the world using these bonds. Your mission is to find out what is going on, then, as usual, destroy everything. You'll need to keep your electrons about you.
I'm not in the habit of losing them.
I've arranged for Agent O2 and her cousin to assist you. The password is AU.
Seen you around here before, big boy.
I'm new around here and don't know much.
You look quite bright to me.
Actually, I'm unusually dense.
Hey, you. Looking for a bond?
Only if the chemistry's right.
Welcome, Gold. Where do we start?
By telling me the name of that atom with the blonde Bond shell.
That's Chlorine, queen of the bleach. She's poison. You don't want to know her.
I'm not so sure about that.
Uh-oh, the heavies. That's Carbon, the big boss. Pressured most of the atoms around here into working on a secret project.
Where is this secret project?
Behind that wall?
It's pure diamond. Hardest substance there is.
Harder than me?
It is possible, you know, Gold.
Yeah, really? How?
Each atom shares 4 electrons with 4 neighbors. The electrons hold the atoms in place evenly from each direction. This is called covalent bonding. This pattern of atoms can continue forever and is known as a network solid.
Any bright ideas on how we can get through this thing?
Yes, actually, but Carbon won't be pleased. Thinks diamonds are forever.
Aren't they?
All we need is more oxygen and we'll burn our way through.
I could have done that, and faster.
Oh no! Another covalent network solid! How many more of these are there?
Well, 4, sir. We've seen carbon as diamond. We could have silicon carbide or boron nitride. But here we've got silicon dioxide as silica, which I can't do a thing with.
Stand aside, oxygen. Fluorine's the only atom who can attack silica.
What is this building?
It's a school for atoms. Teaches them how to react to different situations.
I can hear a crystal marching in formation.
Quick, get back! Heavy atoms!
This way. The projection room for the auditorium is through here. Today, class, you're going to learn what you can each achieve. You atoms have a class structure depending on how many electrons you have in your outer shell. This dictates how many bonds you can form. Halogens are at the bottom of the class structure and can form only one bond, fluorine to iodine.
That's you, fluorine. Bottom rung.
Oxygen and sulfur can form 2 bonds, nitrogen and phosphorus 3, and carbon and silicon 4. Carbon is on the top and runs the whole school. Oxygen! 17, yes, you! Spit out that extra neutron. I'll have no isotopes in this class. Now, gases, it's time to learn about bonding with another atom. The idea is that you all want 8 electrons. Right?
Right!
Fluorine, you already have 7 electrons in your outer shell, so you only need 1 more electron to make 8. Oxygen, you'll need 2 more, and nitrogen, you'll need 3. Could I have 2 chlorines and an oxygen to the front of the class, please? Thank you. Now, let's see what you're made of. As you can see, chlorine has space for 1 more electron and oxygen 2. When they combine, their outer shells are filled because they share their electrons. This is covalent bonding, and here we have an OCl2 molecule. Molecules are quite different to the diamond wall we used to keep you lot out of the casino. In diamond, the carbon has covalent bonds, but it forms a network as opposed to a molecule. A network can go for any distance, whereas the molecule has a predetermined limit. The smaller an atom is, the stronger it holds its electrons. If, for example, bromine and fluorine were to combine, the electrons will be closer to the fluorine than the bromine. The fluorine will be more negative and the bromine will be slightly positive. The result is a polar molecule with more charge at one end than the other. Okay, try that with a partner of a different size. Phosphorus, you've combined with 3 chlorines. The negatively charged chlorines are on one side and the positively charged phosphorus on the other. And sulfur, you've made a boomerang shape with your 2 negative chlorines on one side. Your charges are lopsided, and you are known as polar molecules. Your uneven charges allow you to create a chain where the positive side attracts the negative side. The result is that you will become a liquid very easily. If atoms of the same type share electrons, the charge is evenly distributed. This means the molecules do not attract each other and can't easily become a liquid. Hydrogen atoms will covalently bond with oxygen to form water, or with nitrogen to form ammonia. The positive hydrogens will be attracted to the negative oxygen or nitrogen of another molecule. This allows you to form a special type of dipole-dipole bond called the hydrogen bond. You hydrogens are the only atoms with a bond named after you. It's the strongest of the dipole-dipole bonds, but is still only 1/10 as strong as a covalent bond. Hydrogen bonding is especially useful for Project D.
That's the secret project.
The mysterious Project D. Might be a good time for me to meet chlorine.
Gold, be careful, she's dangerous. There's no knowing how she'll react.
Chlorine, you know what to do. Entertain him, find out what you can, then call me and I'll send the boys over to polish him off.
He looks polished already.
Well, hello.
Mr. Metallic Bond, I presume?
Call me Gold.
Oh, I will call you Gold. You're not looking for a bond, are you?
Why? Do you know of any?
Let's just say I think we should work together on this one. So, you're the atom with the golden electron.
Or chlorine, the atom with the blonde bond shell.
Are you into bonding, Gold?
Well, they do say I'm rather good at metallic bonding.
Ooh, metallic bonding. I'd like to try that.
Well, Chlorine, you really need to be a metal.
Why is that, Gold?
Metals have 1, 2, or 3 electrons in their outer shell. Just like the covalent class, we share them with our neighbors. The difference is the electrons are free to roam. We crystallize into groups of atoms with the electrons whizzing around from atom to atom, binding us together.
We non-metals share electrons, but the electrons can't move around. Oh, my electrons. I bet it's carbon.
Don't worry, Chlorine. Just hold on tight. Quick, Chlorine. Pretend you're one of the band.
But how will I disguise my blonde bond shell?
Pull an electron off one of the potassiums. With your shell complete, you'll be bigger.
Positive potassium ions have attracted me in all directions. I'm stuck in an ionic bond. Farewell, Gold.
Come in, HQ. Come in. We need some backup here.
Sir, solvent water reporting. Give me ionic bonding and I'll break its neck.
You don't look big enough.
Size doesn't matter. I have a charge on each end, and these attract the ions and break the bonds. The salt dissolves.
At ease, coppers. Good to see you, Silver.
Captain, sir, you finally made it to our underground resistance station.
Resistance? But the coppers seem to be conducting themselves well. Secret Agent Silver, why haven't I seen you out in the streets?
Well, I'm not very secret with AG for Agent tattooed right across me.
Well, there's been a public redox incident, sir. Completely blocked Vanadium Street. And my troops were able to dissolve most of the salt and brought 2 down to the station. We put them in the cell, waiting treatment. This way, sir. They're wired up and ready.
Right. Chlorine, you seem to be in possession of a stolen electron.
How can I get rid of it?
We're going to have to charge you, Chlorine.
What with?
4.5 volts. Okay, officer, hit the switch.
Oh, Copper, however can I thank you for freeing me?
No, Copper. Back in line. Stay away from her, whatever you do.
Too late.
After being with Gold, I'd forgotten my own strength. Will the coppers charge me again?
No, Gold will do it next time.
Oxygen and fluorine were here when I left.
Carbon has captured them.
They'll react strongly to that. Wonder what's going on here now.
Right then, Nitrogen. Now that you have learned how to covalently bond, well done, by the way, it's time to learn about the London Dispersion Force. Could I please have 2 volunteers? Thank you, Nitrogen. You too, Nitrogen. Let's look at your electrons. Good, good. As you can see, your outer electrons are buzzing around at a fantastic rate. They move unevenly around your nucleus. At brief moments, you can even become slightly polar. When the temperature's low enough, you don't have the energy to resist, and are attracted to one another in much the same way that polar molecules are. Now, class, I'd like you all to try. Guard, turn down the thermostat. Okay, everyone can slow down now. Yes, that's right. As the temperature drops, join up with your neighbours and you'll form liquid nitrogen.
Well, well. It appears our old friend Carbon has arrived.
Gold, I think they've seen us. My God, Gold, you've been hit.
Don't worry, Chlorine. Electrons won't stick to me like they do to you.
That way, you fools!
That's a stroke of luck. We can pretend to be shopkeepers. Agent 02, or should I say 03. I didn't recognize you as Ozone.
While I was waiting for you, Gold, I was hit by lightning.
Remember, you don't know me.
I'd like a good, stable bond for this extra oxygen.
Well, we have a range of bonds on offer. It depends on which atom you are and who you want to combine with. Here, have a look at this chart. In your case, you can go ionic with any of the group 1 alkali metals. I've just been in an ionic relationship myself.
You're a handsome atom. What sort of bonds do you do?
I do metallic and ionic.
Can I do ionic with you?
Not without me. Gold is mine.
Ah, she wants me.
You, oxygen, can choose almost any atom except for gold. I think nice simple molecules for someone like you. For example, carbon monoxide, carbon dioxide, nitrous oxide, nitrogen dioxide, or H2O, which is water.
Is that the best you can do, Chlorine? I think I'll find a better offer elsewhere.
What's going on? This is my shop.
I was just leaving anyway.
Good. We've had enough of your airs, Ozone.
No time to chat, Bromine. Duty calls.
I'll get the carbons onto you.
I'm not with them. They're spies who want to sabotage Project D. Project D? Who told you about Project D?
Mind you, we could use an atom with your properties. Would you like to join us?
Well, maybe.
You would have to promise not to turn me to water.
Nor me to oxide.
Think of it, Oxygen. If you join up with us, we will be able to form the most magnificent molecules imaginable.
All right, then. I promise to be nice and sweet. For you.
Good. We'll put you on the glucose team. You'll be working with carbon, hydrogen and oxygen, codename 8, to make carbohydrate. After that, I have something more complex in mind. If we work together on Project D, we can take over the world.
You can't touch me, Carbon.
I can't on my own, but with nitrogen, I can. Move in, Cyanide! At last, the perfect solution for gold.
Cyanide ions. In the presence of oxygen, I have no defense. Chlorine, try to get the message.
Gold. Can you explain what's going on?
Well, cesium, carbon, nitrogen, hydrogen, and now oxygen are combining and are up to something big and complex.
Any metals in it? What do they call it?
It's called Project D. Na is in it, combined with chlorine. Ah, room service. I'll have the continental breakfast, please.
Don't get smart. Carbon wants to see you.
On your feet. You're coming with us.
Ah, there you are, Mr. Gold. As you can see, I have chlorine captive in my buckyball. I had thought to covalently bond with her myself and make carbon tetrachloride.
Leave her alone, and I'll go quietly.
Release her, oxygens! Glad to see you've come to your senses. Now I have things to attend to. My head chemist, Ethanol, will show you around.
You and your pitiful cesium would never be able to achieve what carbon has done in only 10 million years. It's going to change the world forever. Project DNA. We're programming in a very complex message by the arrangement of these molecules. Once we've made the first one, it's easy to make copies, all based on hydrogen bonds. Place a copy next to this one, and when it is finally assembled, we can peel it off by breaking the hydrogen bonds like a zipper. No damage to the original.
Attention, all participants, attention! Climb aboard and take your places for the first test flight.
Gold, shouldn't you be destroying all this? It's the done thing.
Yes, you're right, Chlorine. Coppers, go, go, go! There. You'll never get your crew in place now. Project DNA is doomed.
Why don't I ever learn? You show prisoners your secret project, and they smash the place to pieces. I've had enough of you and your foolish attempts to thwart my plans, Gold. I never want to see you again. So I've arranged a special type of bond for you. Throw them in! Acroregia is the solution you both deserve.
Shall we bond, Chlorine?
I've been waiting for you to say that.
Gold! I want you out of there and back at work immediately.
Sorry, Cesium. Situation's become quite complex.
Well, covalently bonded, you're full of surprises, Gold.
They call me simple, but I bet carbon never got this complex.
Of course not, dearest.
Okay, everyone. In your places. Prepare